Hello everyone. Good evening, all of you who have joined. Please share the link so that others can also join our session as early as possible, so that we can start the session by around 9:05. Hello everyone. Good evening, all of you who have joined. Hello, all of you who have joined. Good evening to all of you. We have 4 members now. I hope all of you will join as early as possible so that we can start the session. We'll be starting by 9:05. So please join fast. Please let me know if my voice is audible. Is it fine, or is there any issue? Yeah. Good evening. Good evening, Shahid sir. Am I audible properly? Please let me know. Let me know in the comment. It's 9:03, so we'll be starting the session in just 2 minutes. Let's wait for others to join. Okay. Okay. Fine. Thank you. Hi, Srinivas sir. Good evening. Hello, Subhash. Good evening. Okay. Okay. Fine. Thank you, sir. So the basic things actually I have explained in my previous sessions also. So today what I have thought, maybe I'll be completing a total project with the basic inputs, and we'll also how we can import the CAD files. We'll see that also. Even we have done this previously, and we'll do that today also. Few of you who have already joined in my previous classes, you guys know how to do these things, but we will again revise these things, right? So I think we can start now. It's 9. Okay, 9:04. Let's wait for just 1 minute. Exactly at 9:05 we'll be starting the session. So this is the plan that I'm going to explain today. I have chosen, there is another plan. Let me just show you. So this plan is also there, but it's quite big, and it seems like we have the columns and beams like in straight manner. So I just thought of doing this one. It is a duplex floor plan though, just G+1, but what I'm thinking, like the positioning of the rooms are a bit different, you see, and it's not like straight beams. There won't be straight beams and all. So that's why I just thought of considering this as our demo plan. Okay, so these kind of plans actually anyone can download from Google. I have downloaded this from Google only. It's not made by me. So you can also download this kind of plans, and you can practice in Etabs or any other software. It is pretty good. Like it's free to download. You can always practice it. We can also do this project later on. There is time, we will also touch this project. It is very simple, like straight grid lines we have. The columns are also on the grid, so we can easily do that. Okay, so but for now, initially we will start here. Here the column positioning is not given. The beam placements are not given. So we will decide how to put the columns and beams, right? And accordingly, we will plan in Etabs. Okay, so let's start now. I think there is no like already it's 9:06 and we should start. It's already late night. Late night, that means it is winter here in our area. So means in my state it's totally winter here. So it's 9 means almost it's like 11 o'clock in the summer. So I think it is better to start. So if you see, let's begin from the ground floor plan. If you see, this is the ground floor plan with furniture layout, with detailed, you can say layout. We have the parking area, the toilet, the water closet. Here you can see, and this is the kind of the dimensions we have for all these rooms. Okay. Now our concern is first where to place the columns and how to place the beams, right? Now let us just see here. If you see this ground floor plan, that means this will be the plinth level, okay, or you can say ground floor. So the beams we will be drawing here, those beams will be at the plinth level, right? Those beams will be at the plinth level. Hi Vishal, good evening. So these beams that we will be drawing in for this ground floor, it will be in the plinth level, and the beams we will be drawing here for the first floor plan, it will be in the you can say the first floor level, and after that we will be having the roof level, which is not there, which is not given here. Okay. Now the problem is, if you see the ground floor plan, it is pretty straight here. The walls are pretty straight with it is aligned, so we can easily put the columns. But if you see the first floor plan here, this particular area, this the wall is shifted from here. Okay, previously in the ground floor plan the wall was here, but now it is shifted here. Again, there is an inclined wall. So suppose you have thought of putting the column here somewhere here, suppose like this, but as we do not have this particular area in the ground floor plan, in the first floor plan, it is something like this. Now what will happen? This column will be at the front area, or you can say in the open area, and here we will have the door. So front of the door you have a column. It's not a desirable condition, right? So we need to understand where we need to put this column properly, right? Hi Digi sir, good evening after a long time. Hi Maya, good evening. how can I get this DWG files? Okay, now if you want this particular DWG file, please send me a mail or just put your mail here, mail ID here. I will try to send it to you. Okay, you can also download it from Google if you search like floor plans, DWG free download, something like that. You will get lots of plans and you can practice actually. If you want this particular plan specifically, please send me a mail. Let me just write my mail so that you can send me a request. Okay, it's this one. Okay, I hope it is pretty clear. Sandeep Dev 321@gmail.com. You can send me a request for the file, and I will send this file to you. Okay, because obviously it is free for use for all, so I can easily send. It's not a project of me or anyone else. It was available in the Google, so I can send it to you also. There is no issue. Okay. Okay, so you want the earth pressure to be calculated. Actually, in this plan, there is no way of designing the basement because it's a G+1. See, it is pretty easy actually how to calculate the earth pressure, and I have the Excel sheet prepared already. Yeah, I will try to show you that actually what are the formulas you get to calculate the soil pressure. Okay, Mr. Abhishek said. Okay. Okay, let's now start positioning the columns and beams first. So I will go with the beams first. Just the rough planning we will do here, and then we will create the CAD plan. So if you see here, it is very simple, I guess. Let me just put the columns first so that it will be easy for me to put the beams. But initially, we need to draw the beams first and then put the columns, because the columns will be in the beam junction, right? So here, obviously, we will put one column. I hope it is pretty clear to all of you. I will put another column here. Maybe you may ask me to put one column here, but it's 12 and plus 6 feet. So it is kind of 18 feet, right? So I think it is better to put a column here. One column here, obviously, because it's stair area. One column here. Okay. And now, why I am doing it in the first floor plan? Because in the first floor plan, we have this issue. We have this criticality. We have this problem, right? So that's why this plan we need to actually, in this plan, we need to put the columns. And this column will be continued at the bottom also. Okay. And you will see that even if we place a column here, suppose we will be placing a column here, it will not disturb the ground floor plan, or it will not disturb anything in terms of architectural placement, maybe the door placement and all, in the ground floor plan also. So we can put one column here. Obviously, it is not recommended sometimes. It is not recommended to. It is always recommended to put 4 columns at the 4 corner of the staircase. But in that case, we can go with here because it is just G+1. So then I think we can put 2 columns here, right? I can put 1 column here, 1 column here, and 1 column here, 1 column. Is it required 1 column here? I think we can put 1 column. Okay, fine. Then obviously 1 here, 1 here. So I think it is pretty fine. Please let me know if you have any suggestion for the column placements. Yeah, good evening, Yashwant. Actually, there was so many things going on, so I couldn't manage time to go live. But like for last few weeks, I was thinking to do it again. Thanks that you were concerned about it. Really means a lot for me. People are concerned about my life sessions. Thank you. Okay, so I think the column placements are pretty fine. If you have any suggestion for the column placements, please do let me know. I will try to change it, or I will try to put it as per your suggestion, and we'll see which one is the perfect one. Okay, so let me just right now draw the beams roughly. Maybe obviously here I'm drawing the beams with this pink color. So it will be kind of like this here. Maybe if you want, you can put a small beam here, secondary beam, but maybe you can ignore it also. But okay, let's see. If we want, we will do that. I will give one beam here. Obviously, I will continue this beam and here like this. Okay. Now here I will create this particular area, the balcony area. Okay. And I will give this one. Fine. Then what we can do, we can give this beam and we can this beam like this, right? Obviously it is living area, it is not desirable to have a beam here, but we have no other choice to do that actually. Instead of doing things like this, we have to do this actually. Okay, so because this is a residential building, and we will nowadays in every residential apart like this kind of duplex buildings, we used to have the false ceilings, right? So it is fine even these beams may not be visible in the presence of the false ceiling. Then we can see here this particular area is a cantilever slab, and there is no loading actually. It is just opening for the, we can see the facade. Okay, it's kind of a facade, a projection, you can say a projection. It will be working as a window shade, and also like for the architectural view. So the beams we can place here, the beam. Okay, and from here we can extend a slab. Okay, and the main area is the balcony here. So I guess it is pretty fine at the bottom, the plinth level. Obviously here we have one beam, basically, right? Because the staircase will be starting from here, so we need to have a beam at the plinth level here. Fine. So what we will do, we will draw a grid line here so that we can draw this particular beam in the plinth level. So at the plinth level, we need to change. I think it is pretty fine for the plinth level also. I will just check. Okay, so what I will do, I will take a screenshot of this. I'll take a screenshot of this so that I'll just snipping tool I will take. Fine, I will save it. Okay. Now I will check with the ground floor level. At the toilet area, instead of 2, we can put 1 with leaving the bedroom column. Let me just check what you are. So you are saying that with the bedroom column? No, I don't think we can do that actually. Okay, so here you do not want one column, right, in between. But I just wanted this for this particular beam because there will be lots of beams connecting together. So just wanted this column to support this beam at this end. Okay, so we can see if we can remove this. Otherwise, this span will be higher. See, it is 5 feet, 9 feet, and 12 feet now. This higher span it will be, I guess. Okay. Fine. So let's check for the ground floor now. What are the issues with the ground floor? So the column for the ground floor, the column that we have provided here, the column will be coming something around at this place. Okay. So there is no issue. We have this door. We can easily do that. And here, if you see, the beam that we have in the first floor, it is here. It is somewhere here. But here, the wall is shifted. So for the ground floor level, means for the plinth level, we can do that. We have, I guess, like this, the beams like this. So instead of giving this beam, so it is ground floor, we need to have a beam here also to support this wall here. So again, we have a column like this, I guess. So in this place, let me just open the diagram. So in this place, we need to have a beam in the ground floor, that means in the plinth level, right? In this, at this place. And yeah, obviously we need to have this beam to connect these two columns. Will be kind of a tie. So let us now just do this. What I will do, I will create the grids in AutoCAD so that it will be easy for us to do it in Etabs. Okay. So to create the grids, I will just open the layer property with the LA enter command, and I will create a new layer with a name called grid. Okay, I will give a fade color, and instead of continuous, okay, let me just keep it continuous line, and fine, close. Now I will go for grids, right? So before that, I will maybe I will click on any depth point. Is it there? It's not there. Let me create another one. Null. Fine. I will give it a yellow color. For my understanding, I will select the null. What I will do, see here we have these windows. So let me just check. Yeah. So these lines will work for us. Let me see if for any of the walls, I think we don't have for this wall, the smaller walls. Okay, here we have actually. Let me just check. What I am trying to do, I need the center line of these columns, right? So what I would be doing, I will be drawing a line like this, and I will be placing the construction line in the center, like at the mid of this line. But if we have the lines, this reference lines, so we can easily do that without creating the null line also. Okay, so let's just jump into the grid. So I will click on grid, and this process actually I have explained in my previous classes. So now I will take the construction line with Excel enter, and for the vertical I will take V enter. Here we have got the center point for this wall. For this wall, I don't know. Yeah, for this wall, we don't have the center point, right? So we need to draw a line, L enter. I'll just draw a line like this. In Excel enter, V enter, and I will draw a vertical line like this. Now I will delete this. Again, Excel enter, V enter. Here I will place one. Here I will place one. Here I will place one. Okay, fine. See, for this wall I don't have, so I need to draw a I think I don't have here, right? So I need to draw. For this wall I will take. For this one I have. Fine. And this projection we will calculate manually, and we will draw the position of the beam. If you want, you can actually draw this slab construction line here. So let me just take a line command for this first, and also for this particular area where we'll be putting the beam for the cantilever part. It's like here we'll be having cantilever beams. I think it's not draw. Yeah. Instead of doing it at the ends, what you can do, you can just push it back here and keep this part cantilever. I think it will be desirable. It will be good. Yeah. Instead of placing the columns here, just show you, instead of placing the columns here, what we can do, we can place the columns here, and this part we can keep cantilever. Okay, a small part it is, so we can do that. Okay, fine. What I will do, I will draw a line here also. Already drawn here. Now Excel enter, V enter, and I will draw the grids. Here also, where is the line? Here is the line. Excel enter, V enter, draw it and delete. So be careful about these small lines. It may cause problems if you are not deleting it. So you have to be careful about it. So I think all the vertical grids I have drawn, that will be useful for me while drawing this particular plan in Etabs. Okay, I'm not going with the floor plan option now. I will be going with the grid. Okay, today, because floor plan option I have already explained in my previous session. Now again I will go for the horizontal construction lines, and I will place it like this. Here for this one, yeah, we have. For this one we don't have, so we need to draw a line. Okay, and for this we have, fine. This shifts, that doesn't matter. We can draw, and later on in the detailing we can shift this walls actually. Okay, not have to worry about that much precision actually. Not an issue. Here, because we need to keep the finite element model as simple as possible, which is representing the actual model. Okay, which is representing the actual structure. But again, the finite element model that we are creating, that is not same as the actual structure that will be constructed. Okay, so obviously what we need to do for the mathematical calculation, to like, it is not desirable to make the structure or make the model complex. Okay, so keep it easy, keep it as easy as possible or as simple as possible. But while detailing, that's why detailing of the structure is very much important and very much crucial part of the structural design procedure. While detailing, we need to keep those in mind, like where to put the columns properly, and where to put the beams, how to put the beams and walls properly. Okay, so I think we have drawn everything. Is there anything left? Need to check. I think we have drawn this for wall also. Okay, this wall, for this wall we don't have. For all horizontal walls, I think we are done. Yeah, here I will put one because I need to draw this particular beam at the plinth level. Okay, so let's draw this also. I'll enter. We'll draw this. Excel enter. H enter. Here. Okay, let me just thank you, Digvijay sir. Okay, fine. So we have drawn the construction lines. Now what I will do, I will just trim it a bit. So I will see which, okay, these are the dimensions. I will just lock the dimension. Let me see where it is. Turn off this. These are the walls actually, boundary walls, I guess. I will turn off this also. Okay, so this is my plan, and what I will do, I will just draw a rectangle like this, and I will trim the extra parts. Okay, now I will delete this rectangle. You can delete these extra lines also. Okay, and I will turn on the wall now. Fine. So we have the grid. Okay, and we have now this grid will be used in Etabs to create our model. Okay, so what I will do, I will just select the grids like this, all the grids. I will copy this, Control C, I will create another drawing. Okay, and I will set the units. Let me set the unit first. Precision 0 maybe. Okay, engineering. Feet and inches we want, and we want the unit in inches because the drawing that we have created, it is in inch. If you see the units is in inches, so the same unit we need to keep it here. Okay, so I have taken this drawing here, so I will now paste it, Control V. Okay, now what I will do, I will place it in this particular zone 0, 0, 0 point, this corner. Okay, so for that I will take a line and I will give the coordinate value 0, 0, 0. Enter. You can see the starting point we have got, and I will select this, move this point, delete this. So we have got the grid. Now we need to save this. Okay. Okay, let me take some questions. If you have any question in between. Sometimes it used to be very boring if you only see the, or if you only watch the demonstration. Is there any suggestion, any comment, or any question you can ask actually in the comment, so that I can like the class should be interacting, as Digvijay sir said, it should be interacting. Otherwise, these classes used to be very boring, right? So what I will do, I will just save this maybe somewhere here. Let me create a DXF file for this. DXF, okay, and I will save it as DXF. Any version, I will take a smaller version, maybe the lower version, sorry, and I will name it X demo. Save. So if you see, these lines are in the grid, you can say the grid layer. So what I can do here, I can just purge the other layers, purge all checked items, so that only the available layers will be there. Otherwise, all other layers will be deleted. Okay, so let me just save it again. Save as duplex demo DXF. Save. Yes. Otherwise, it will be very confusing actually if you have hundreds of layers and you need to choose one layer. Then in that case, it used to be very confusing. So what I have done, I have given the purge command, which have deleted all the unused layers in this file. Okay. So now I will just close this DXF. It should be closed, otherwise it will not be imported in Etabs. So now I will open Etabs. I hope all of you are pretty familiar with Etabs. I have also done so many videos or so many webinars, okay, so many live sessions on Etabs. So most of you are pretty familiar with Etabs. So I do not have to explain all this, the basic things here, I guess. So what I will do, I will create a new model. Obviously, I will click on new model here, and I will take this option, which is use built-in settings with. The reason all of you know, if you do not know, please do check my previous sessions. It will be easy for you to understand them. Okay, so I will choose the built-in settings with, and I will go with, obviously, now here I will be going with metric SI unit instead of going with foot inches. In India, we used to deal with meters and mm, right? So I will go with metric SI. Obviously, if we want to use any steel section, obviously we will be taking from Indian database. Steel design code 800, IS 800, and concrete design code IS 456. I'll click on OK. Obviously, as I will be importing the grid, so I will choose blank. Now, this particular thing is very interesting. Simple story data. Okay. So if you see this particular plan, it is G+1, right? So let me just, I have explained these things previously also. It is G+1, very small, right? So the number of stories will be 2. Now there is an option in Etabs which is called bottom story. Now, in such cases, what we used to have, like if you have a basement, that is different. Okay, if you have such cases, very small structures and this kind of scenario, how we used to provide the beams first, like if you see, like this foundation, then column, maybe here we have the ground level, then the column will go up to the plinth level. Here we will have the plinth level. Obviously this column will be continued. We just delete this. It will be continued, and it will be continued like this. Then we will have the first floor. So this is my plinth level. So if you see, most of the people, this is the mistake that people used to do. Most of the people, what they do not consider this particular length. They only consider the plinth to ground floor length and provide a restraint here. But the problem is the restraint that we are providing in any software. Sorry, I have just deleted by mistake. Okay, let me just draw it here again. Fine. So the problem with that particular approach is that the restraint that we are providing, that restraint is actually the interface, or you can say the phase where the column is meeting with the footing. So here, whatever condition we have, or we want to see whatever condition, fixity condition, that fixity condition we used to provide in software. Now, if you break the column here and provide the restraint here, that means the software is considering that here we have the footing. One more thing, one more issue is, like if you are only providing this much of length, then you are not designing the column for this whole length, right? You are not designing the column for this whole length. So in that case, obviously for the smaller column, the effective length, and for this whole column, the effective length will not be same. So the forces that you are getting, it will not be same. Obviously, we want to column as a whole. We want to design this column as a whole from here to here, right? So that's why it is always desirable to model this column. So this particular level, from plinth level to top of the foundation, from plinth level to top of the foundation. In my previous, all my videos, I have explained this actually. All my previous sessions, I have explained this thing very clearly. So I don't think anyone have any issue here. Make videos on UG and overhead. Okay, I will try to make that actually on the overhead tank, but that is a different topic. Let's discuss about today's topic. So this particular length we used to consider as bottom story in Etabs. Okay, it is in Etabs. So actually, what happens in Etabs, there is nothing like, Etabs will not understand whether it is under the ground or it is from the plinth to bottom till the top of the foundation. In bottom story, that means the last story you have. Okay, the last story you have. So obviously this is the last story we have. Now if you have a basement, suppose you have a basement like this, just delete this. So if you have a basement, suppose this is my column, it is continuing, and maybe we have basement like this, the basement wall it is. So in case of basements, what we used to do, at a very lower depth, we used to provide the raft. If you want to use the raft, suppose you have a raft and you want to use this basement as tilt floor, okay, or maybe the parking area. So in that case, obviously, you may provide a very lower depth as we are going with the raft. So in that case, that the steel floor itself, or the floor height itself, is the bottom story. In case of basements, okay, bottom story. So this part will be underground, but this whole area will be considering as my bottom story. So this is the similar thing you can see from here, top of the ground level to bottom of top of the foundation. So it's the same thing we are considering. The only concept is the last story we need to consider as bottom story. If you are considering from ground floor to plinth level, or ground floor to maybe first floor, so it is not the real case. Okay, in the plinth level also you will be having these tie beams or maybe the plinth beams, right? So in that case, obviously the effective length of the column will be changing in certain directions, maybe in 2 directions also. So you need to actually take care of this thing. Okay, so I think this is very clear to all of you. So we have G+1 plus bottom story, okay, plus our if you have a stairs, obviously the stair room. So how many levels we need? G+1 2 plus bottom story 1 plus stair room 1. So we need actually 4 levels. Now for the bottom story, suppose we are considering 0.6 meter 600 mm plinth level from ground floor to the plinth level, okay, if it is PL, and here we are considering the foundation depth, this depth actually we are considering, suppose it is G+1, so maybe 1.5 meter. So 1.5 plus 0.6, this will be my bottom story height. My G+1, this typical story height, we will consider 3 meter. Maybe sometimes you can go with 3.2 or 3.6, something like this, depending on your criteria. And for the stair room, we will go with 8 feet or maybe 2.5 meter. Okay, so now let's see how we can do that. Let's just close this. Here, obviously, we have got the number of stories. We will be having 4. The bottom story. So here you can do the calculations actually. It will be 1.5 plus 0.6. Here it is saying what should be the max length we consider for plinth to footing if we have hard strata at very more depth. See, now when you have hard strata in very higher depth, so we'll be having higher, you can say, deep foundations, right? Not the shallow foundations. So in case of shallow foundations, as per my knowledge, it should be like 2 meter, 1.5 meter, something like that. More than that, we will be going with maybe, yeah, you can do that also. You can go with 3 meter also if required. But obviously, if the soil condition is so bad, so we'll be going with deep foundations. There is no such criteria, I guess. There is no such criteria. Obviously, if your strata is at the higher depth, so we'll be going with, you can say, the deep foundations. So let's see now. Typical story height, so we will go with 3 meter. Bottom story height 2.1 meter. Now the top story, that means the stair room, we cannot give here, right? So as we have given this data here, so now if I click on this custom story data and click on edit story data, you can see this particular thing is created here, right? All these levels are given here. So what I will do, I will just change the value here as 2.5. Again, this thing you can actually change afterwards also after opening the file, but I have just changed it here. Okay. So what I will do, I will change the names also, maybe plinth level, first floor level. So I will write like this, first floor level. It will be my roof level. So I will maybe write roof. And here it will be top of the mumty room, right? So anything you can write, maybe UHT, whatever it is. So stair room, top, whatever it is, maybe I will just write it as top slab. Okay. So just for your understanding, you can write anything. And I will click on OK and OK here. So now we have this blank page. I will just close this 3D view now. If you see here, this arrow we have, you can create numerous windows. There is no limitation. You can add as many windows as you want, but I am very comfortable with one particular. Now I will go to the plan level of plinth. Okay, so this is my plinth level and we don't have any plan. So let's import the grids now. I will go to file and I will go to import. Here you have architectural grid. Let's see here, DXF file of architectural grids, right? I'll click on here. I will go to the file where I have saved duplex demo. Okay, open. This is my layer. see, that's why I have deleted all the unused layers, because it is now easy for me to understand which layer I have used for the grid. The DXF file in it was in inches, right? And okay, this is the tolerance. Actually, we can ignore the lines which are smaller than 1 mm. The global X up direction is Z, obviously. Click on OK. Now I will save it somewhere, maybe here only. I will create a folder, Etabs, and I will name it as duplex demo. Okay, save. So now we have got the, see how easily we have got the grid. Actually, what we can do, we can change this. See, here we have 1 2 3 4, here also 1 2 3 4, so this is not required. I will just go to edit grids, stories and grid systems. I will modify this. Now in the X direction, if you want, we can keep this 1 2 3, otherwise you can change this one only. So maybe I will go with A B C D here. Just type A, like this you can do. Fine. So if you are working in different architectural firms, architects used to avoid O and I in the grid. Actually, why? Because if you are giving it I or O, sometimes people may confuse these things between 1 and 0, right? So that's why they asked us to avoid I and O in the grid. So instead of I, you can go directly J. Okay, so you can keep it I also. That is totally depending on you. If you are only one working for your project, so it's totally up to you. There is no such rules. But architectural firms, they do want this kind of annotation. Actually, I and O should be avoided in the grid. So I will now click on OK. Okay, so we have got this grid. Now, according to this grid, what we will do, we will draw the beams, right? So before drawing the beams, let's just define the materials and sections a bit faster. I'll just add Indian material, maybe concrete, M25. Okay, and I will go for the steel, that means the rebar, Indian standard of 500, and also 415 for the stirrups. Fine. Now let's define the section properties, frame sections. I will edit this concrete beam, modify. Material name, it will be M25, maybe it will be B, something around 250 by 400. Width, we will go with 250 by 400. Because some walls we have 9-inch walls, so 250 is the lowest size that we can use it, right? Less than that we cannot go. And if you are designing in earthquake zones, so I think it is better to go with 250, 300 like this, right? So you can see the code of IS 13920 for these criteria. Now I will go to reinforcement. I will choose this M3 design only. Now this cover, this is nothing but the effective cover, so you need to calculate. Let me just change this to HOSD 500 and HOSD 415. Now this effective cover, if you are considering 8 mm dia bar for stirrups, let me just open the calculator. If you are considering 8 mm dia bar for stirrups and 16 mm dia bar for the bottom reinforcement, that means the tension reinforcement. So the clear cover will consider 25 plus 8 plus half of 16, 8, right? It will be 41. So I will just use 41 as the effective cover here. See, it is covered to longitudinal rebar group centroid. Okay, so now if you have group of suppose, obviously, let me just show you. Suppose you have a beam, and if you have a group of bars, so this is my stirrup. Sorry, properly. This is my stirrup. Okay, and you have a group of bars, maybe 2 layers. So in that case, the centroid, this cover will be something where it will be centroid, I think somewhere here, right? So this distance we need to provide here. We have 3, so somewhere here it will be, right? So it will be my cover to the centroid of the rebar group. Okay, that's why they have mentioned rebar group, because in the beam, if it is a very deep beam, you may have this kind of, or if you have a higher load on the beam, higher depth of the beam, so in that case you may have group of 2-3 layers of bars. So in that case you have to consider the centroid actually of the 3 bars. You have to put the value here. Okay, what should be the max length we consider for plinth? Okay, I think I have already answered this. Now let me click on OK and OK. Now I will edit the concrete column. Maybe I will take a column of 300 by 450 or 400. Let's see. M25, which will be 300, 400. I think 300 by 450 is okay. Let's see if I let me go with 300 by 400. What is the ratio we are getting? D by D ratio 100. Yeah, it is fine. 0.7 we are getting. I will modify this column, change these bars. Now obviously this I want to design the reinforcement, so I will choose this one, reinforcement, to be designed. Now clear cover for columns, it is 40 mm. Now these things are very important. Why? If you see the longitudinal bars along 3 direction, see direction 3, we have 3 longitudinal bars here, right? 3 longitudinal bars here. And if you see in the 2 direction we have 5. So here 1, 2, 3, 4, 5. Okay. So now this particular criteria in that we have in Etabs can create the interaction curve for this kind of distribution also. But in SP16, if you see our SP16 that we use for those interaction curves, we don't have this kind of criteria actually. So what we can do, we can choose the one like for uniformly distributed for both the directions, means in whole direction. So maybe for this particular column, I will just go with just to make sure, maybe 3, 3. Like Etabs can generate, Etabs can generate interaction curve for this kind of distribution also, for any kind of distribution. But for our convenience, what we are doing, we are regenerating or we are recreating the condition that we have in our SP16, right? So I will click on OK. Now you can see we have 3 in this direction, 3 in this direction, and this distribution do change or do affect the result of the moment capacity of the column. Okay, so if you want to check, you can actually maybe in a different session we will see how this distribution of reinforcement, different distributions of reinforcement, do affect the moment capacity of the column. Okay, so we may check in a later session. I will click on OK. And okay, so these 2 beams and columns we have defined. Click on OK. Let me define the slab sections also. So slab 1, I will modify this. I will make it slab 125. Okay, grid will be obviously M25, shell thin, and I will make it 120. Okay. Now I will create one more slab with membrane type. Now why I think I have explained for the stair. Different people have different approaches for the stair. So I'm just showing you one. I have taken stair 200 mm, slab type and membrane, and use this option, use special one-way load distribution. Okay, I will click on OK. So I think we have defined all the required sections and materials. Now we can start modeling the structure, right? So let me know if there is any issue or if there is any problem. I hope I am audible and my window also properly visible. Let me know if you have any issue in that case. Okay, I'll just close it. Now let's see here. We can also open the AutoCAD file for our reference. So if you see the columns in the first grid, here and here we will be having. Obviously, we will change the column size and all afterwards. Once we see the design result, or maybe like what is the percentage of reinforcement we are getting, and after that we can optimize it as per our requirement. Okay, so we will put two columns at these two ends, right? So first and third. Then we will be having one more here, the fourth. Let me just draw again column position. So here, second one, here, here, here. I guess we will have one here also, one here, one we will be having here. Actually, this will be shifted inside, and instead of having here, I will have here, here, okay, and here one. We will have here one here. Okay, fine. So now we can place the columns properly. The orientation of the column we will talk about this later one. Just let me just place it first. Then we will orient it in as per our requirement or as per the requirement of the plan. Okay. Let me just go to the Etabs. So you see, I think it will be very critical for me that need to go here and here. So 1, 2, 3, and 4. Sorry, 1, 2, 4, 1, 3, 4, and 6. Okay, so let me place it. Let me go to this option. You can see quick draw columns, and I will choose the property as column 300 by 400. So we have 1, 3, and I think here we have 4 and 6, right? Then we have 3, 5, like one gap here, and here, right? Similarly in this line, fine, and similarly in this line. Okay, so let me just here properly. So here one gap, here let me see. Okay, one gap, another gap. Then we have here, here, and here. Fine. Now in this line also we don't have here. We have here, and we have here. Right? The other line we have here, so 1, 2, and 3 is not there. 4, 5, and 7. 1, 4, 5, 7. 1, 2, 4, 5, and 6, 7. Fine. So I think we have placed all the columns. Now, if you want, you can cross check actually again cross check with this. Correct or not? This direction we have 1 first, 2 miss, second, yeah, fine, pretty fine, clear. Okay. So I think it is fine. Now we can again open Etabs and we can draw the beams now. Now to draw the beams, we can use this option, which is quick draw beams option, but here you can see the grids are there, so the beam will be divided in between. So instead of that, what I will do, I will just draw this one. I will just use this option, draw beam column brace. I will choose the section which is B250 by 400. I will draw the beams properly. Make sure that your beams are like your drawing points are snapping those grid points. Otherwise, you may have issue in the model. I will just draw the beams like this. I think here we don't have beam. Don't we have a column here? How we have done? Fine. Here. Okay. Just did this. Draw. Here to here. Right. Now I will connect this. This. Here we'll draw the area where we have the balcony, right? Here we have the balcony, so I will draw this. And I think here in this line, let me just check once. The first line we have this beam. I will draw the beam. Now, if you see, I'm drawing in the plinth level, right? So what I will do, I will check once the ground floor plan. And here we have the wall instead of here at the top. So what I will do, I will draw a line here. Later on, I will delete this beam actually. I think we cannot delete this beam, right? Because you see, if I delete this beam, this will have no place to actually rest. This particular beam that we have done. This particular beam will have no place to rest. So obviously we need to keep it here. But that is in the top floor. In the plinth level, I think we can connect this column to this column also. Okay, fine. Oh. So and here we will be having one beam for the stair, right? Anything else? Here we will be having one beam, and this particular area here beam is not required, but if you want, you can put a small beam here. Here also you can put a small beam if you want. We can change the sizes afterwards. Here also we have a wall, and we can maybe hidden beams we can provide. See this small, very small wall we have here. Okay, so hidden beam, if you want, you can provide. I will draw it here. I will provide null beam to transfer the load to the slab. Okay, so I think we are done. Now what I will do, I will just draw the slabs, and then we need to make some changes here, as it is the plinth level. So we need to make some changes. Maybe I will draw a beam here instead of this beam, the plinth level, and the top floor we will have this beam. Okay, so just check. Done or not? Okay, so now I will draw the slabs. I will go to this option, change it to slab 125. Will draw like this. Room wise, it is better always. Let me see. It is always better to draw room wise if there is. But if you see, all the rooms are bedroom, toilet. Here we have a lobby. Here we have living room, bedroom. So almost all the rooms will be having similar kind of loads as per IS 875 part 2. If you see, the live loads are different, right? In case of dead load, it will be similar kind, because we will be having same kind of maybe similar weight of tiles, whatever type of tile it is. So in that case, it is not a matter of concern, but the live load is a matter of concern, which may vary from different room to room. But here it is almost all rooms will be having similar kind of loads, like 2 kilonewton as per IS 875 part 2. So in the balcony, we'll be having a different loading, maybe 3 kilonewton we will come. So let us draw this. No issue. So this area is lobby area. In the lobby also we need to have a higher load, but it is residential building, right? So it is not an apartment building. So in the lobby area, there is no chance of having like 50 people together, right? It is a very small lobby. So we will go with the similar thing here also. And this, actually I'm drawing these slabs for the first floor. Okay, in the first floor, once we copy this, and in this plinth level, we will delete these slabs. These slabs are not useful for our plinth level. I will draw here. I will draw here. I will draw here. Now, for the stair area, different person have different. You can say different approach to transfer the load of the stair. Now, actually, what you can do, you can draw a simple slab like this, and you can provide the loading on this slab, calculating just to transfer the loads to this columns actually. Okay, and like you can also provide a one-way membrane here to transfer the whole load to these columns. Okay, now it is totally up to you what approach you want to have. Different, again I'm saying, a different person have different approaches. Different structural engineers have different approaches for doing it in their own way. So what I will do, I will just take a one-way slab that I have drawn. Okay, now what I have to do, I have to change the orientation of this slab. I will click on assign frame, local axis. I will change it to 90 degree. That means in the, sorry, I think I have not, should be shell, not frame. Local axis and 90 degree. Okay, if I click on show undeformed shape, so I have just created the slab, which is only transferring the load to this beam and this columns directly. Okay, so you just have to put the loads on it, and it will be transferring the whole load to these beams and columns. So this is a membrane type of shell, or membrane type of slab we have to model, element we have to model. Okay, now what I will do, I will just put simply, I will create some basic loads. Let me just save it. Define. I think I don't know what kind of comment it is. I don't know. I think these are bots. Sometimes in live sessions we used to have pause. I don't know. Please, if you want to tell me anything with these shortcut forms, please let me know, because I'm not getting those things. So FIY, okay, fine. Like was F tech, something like that. But I'm not clear about these terms actually. So if you want to tell me anything, just write it clearly so that I can understand. Okay, so let me define some load patterns. I will delete this live load. I will create one. So we have this dead load. I will make it self-weight. Modify. So then I will create the SIDL loads, superimpose dead loads. I'll make it super dead. Add new load. I'll make another live load which is less than or equal to 3. Okay. So if you have live loads which are more than 3, then you can create another. Okay. Otherwise, you can keep it like this only, live load, something like this. But this is my practice actually. What I do, I create 2 live loads in case of major structures, suppose commercial structures or institutional buildings where we may have live loads which are greater than 3. So we need to create 2 live load cases for those. One is less than or equal to 3, and another one is for greater than 3 live loads, 3 kilonewton per meter square live. Because while calculating the seismic mass or while defining the seismic mass, it is always recommended, or it is recommended by the code IS 1893, that the loads, live loads which are greater than 3 kilonewton, 50% of that load should be considered as seismic mass or seismic weight. And those which are less or equal to 3, then 25% of the live load should be considered as seismic weight. Right. So that's why it is always good to create 2 live load cases or 2 live load patterns if you have live loads which are greater than 3 kilonewton. Okay. So live load equal smaller or equal to 3. Add new load. Sorry, I will change it to live. Modify. And I will name another live load which is roof live. Roof live, and add new. Now why I have created this roof live? Because the IS 1893 again says that unless or until you have constant equipments on the top of the roof, you should avoid considering the live load on the roof for calculating the seismic weight. So if you are assigning the roof load on this particular load pattern, you cannot deduct it from there, right? From the seismic mass or seismic weight. So that's why I have created another load case for that, so that I can just I will not consider this load for the calculation. Fine. And okay, so I will just select this gravity load cases for now, and I will click on OK. Save it. Once check the load cases also. See here, the name of the dead load case is not changed, so we can just change it. So SSW for your convenience later on, so that you can understand easily. Self weight, or you can write it properly like self weight or something. I will just give it SW. Click on OK. Fine. Okay. Now what I will do, I will define some uniform load sets. So I will click on add new load set. I will define dead equal to 1.5 and live equal to 2 for all general rooms. So I will just write maybe general. I will add here, I will add SIDL and live load less than or equal to 3. Okay, so it will be 1.5 with 2. I'll click on OK. I'll make a copy of this. Here I will add dead load equal to 1.5 and live load equal to 3 for my balcony and stair. Okay, no, for stair I'll not consider 1.5. I need to make it a bit higher. Let me just write it balcony. Okay. Even in this balcony also, that much live load may not come, but I'm just considering it because it is pretty big balcony they have. So I will just click on OK. I'll make a copy. I will create one more dead load which with maybe something around 2 to 3 kilonewton, but you need to calculate actually what is the, see, here in case of the stair, what I have done, I have created a membrane slab, a membrane type of element with 200 mm depth, and the grade of concrete I have considered 25. So the, you can say the load of the self weight of the waste slab will be calculated automatically from here. But we have these steps, right? We have these steps. So you have to calculate what is the load of these steps on the waste slab. Okay. So for now, I'm just considering maybe dead load equal to 2. Maybe dead load equal to 2. Dead load of the stair. And live load, obviously, as per the code, live load equal to 3. And it is for stair. It will be 3 and it will be 2. Okay. I'll make a copy now. Now I will make roof load. So for dead load, I will make maybe 1 to 1.2 kilonewton. Maybe if you have sometimes waterproofing, this kind of thing, so you can calculate the load. Maybe I will take 1.2 kilonewton and live load equal to 1.5 as per IS 875 part 2. Okay, this is an accessible roof I'm considering. So for accessible roof, the load will be 1.5 kilonewton per meters, and this is for my roof. So I will change this load type to roof live now, and I will make it 1.5. I will make the SIDL as 1.2. Okay, I will click on OK. So I think all the load groups. So this shell uniform load set is very useful because you do not have to assign the dead load first and assign the live load first. So it will be easy for you to understand in which area I have assigned what amount of load. Okay, with this set. And then you can directly assign them. So I will just click on OK. Now all the areas I will select like this. Like this. And I will assign, go to assign. I will go to shell loads and I will go to uniform load sets. I will directly assign this general. This balcony, I will assign this balcony load. Stair, I will assign this stair load. Okay. Thank you, Jeevan Kumar. It's my pleasure actually to conduct such sessions because I used to do that previously, but for some reason I think I have done some mistake here. Let me just okay. What you have to do, you have to create the cantilever part also here, right? So let me just do this also. By mistake, I have just forgot. So here, this front beam, I will change the dimension actually. Maybe I will choose a less depth, lesser width also for this particular beam. Okay, so let me just delete this. I will take this from here to here. Change this slab to slab 125. See, if you're not having this kind of shortcuts, you can just right click here and see assign frame, assign shell. So these options are for assign shell, design, draw, everything will be available. These are the shortcuts, and the same shortcuts are available in edit. If you see, all these options are available. Or if you want to go to assign, the assign frame, shell, everything is available. Okay, so now here also we have a cantilever part, but this is not like there will be no loading. So I'm not modeling it. If you want, you can model and give a minimum live load of 0.75 kilonewton per meter square. You can design it. So now what I will do, you see the 3D view. We have this now. I will go to the plan view of plinth level again. I will select this. Okay, and I will replicate this. I'll go to story. See, if you want to go to replicate, go to edit, replicate here, go to story, and see from base to plinth we have already created, right? So now first floor and roof level and top slab level. Apply. Close. I will go to the plan view of top slab level. All these things I will delete. Sorry. Can we have the mumty room here? To have the mumty room, what you have to do, we have to copy these columns also, right? You have to copy these columns also. Okay, so if you want the mumty room, must be, I don't have the elevation here actually with me as it is downloaded. So if I want to have the mumty room, so in that case they may have a different kind of architecture here, obviously, to make it possible or to make it beautiful. See, so obviously we need to select this particular part. Top slab. Actually, what I will do, I will delete this. Delete this. I will delete this also. Okay, so we have to have this column and the beam like this. Otherwise, we cannot do this. So I will delete this slabs and this beam also. I will go to this option and I will change it to maybe tier 125. And just minimum load, I will put it here. I will click on assign. Shell loads uniform will be live load roof light 0.75. And okay. Okay, fine. So now I will go to this level. This is my roof level. I will select all the slabs instead of this. Sorry, except this stair one. I will select everything and I will go to assign shell loads uniform load sets. I will click on none. Okay, except this stair load. Now I will select all this again except the stair and I will go to roof and I will assign. See here, it is very important that make sure that it is in one story. If it is in all story, then all the stories, like automatically, if you are selecting this particular level, everything in every other level will be selected. So I have kept it in one story. Okay, so that I can change it one by one. Now I will go at the bottom. See, at the top floors, we don't need this beam, right? So I will go down. Top floor, I don't need this. So here I need this beam, right? Now what I can do, let me just check. I think we have not assigned anything to this particular area, right? I will just select here also. The roof level, it is not needed. This to assign shell loads uniform load sets, and I will assign this balcony. Okay, let me see if there is any question. Almost 10:22. I don't think we can finish it, right? The modeling and loading will finish the time. Okay, let's see, no problem. There is no issue. Let's now go down, and this is my plinth level. Here I need this beam and I will be deleting all these slabs. Right? Let's see the now structure. So this is my structure. Right? This is the structure we have created in few minutes, or you can say in few hours. 2 hours we have needed. So I'll go to base plan. What I will do, I will fix all these points. Sign, joint, trains, and fixed. Right? Now let's see this in the rendering view. So what we can do, I think by mistake I have deleted any column. I have deleted any column on. Okay, fine. So now what you can do, you can see what we have created. If I press, so what I have done in one of my video, you can in my YouTube channel only, you can see how you can see in the Etabs 19 version how you can get the rendered 3D view. Okay, so what I have done, I have created one shortcut for this, which is Alt R. You can create any shortcut which is not available for this software, and you can get the rendered view. In this view option, we don't have the previous basic 3D render view. We have this show rendered view in ray tracing mode, but it will take a lot of time to render it, right? So I will just press Alt R. How to set up this key, you can just check my YouTube video. Very recently I have uploaded how to get the 3D view, so you can do that actually. So I have pressed Alt R and you can see the building model. Right, I hope it is pretty clear to all of you how we have done this. And at the plinth level, this cantilever part is not required, I guess. Let's see what is the ground floor plan we have. Yeah, the plinth level, we don't need this cantilever part, so I will just go to the plan view, plinth level. I will delete these beams. Okay, now for all other levels, what I will do, I will change some beam sizes. So I will just go to assign frames and I will click on modify. Let me go from here, define section properties and frame sections. I'll make a copy of this beam, add a copy of property, and I will name it beam. Maybe now I will just a very small beam, 150 by, I don't know, 150 by 300, like this. 150. I think 150. Not possible. Yeah, 150 is possible. 150 by 300 or 200 by 300. No, 150. Let's 100 by or 350. I will go with 350. And everything will be same. Okay. So these beam, these two beams. So these two beams I will make it is a maybe beam is hidden beam. So in that case, if you do not want to make it hidden beam, then you can assign this actually. Assign and this 200 by 350. And if you want to make it hidden beam, then what you have to do? One thing is you can transfer the load to the slab, but by just creating, you can say by just creating a null beam here. Like if you select and assign the null property, none property, it will be a null beam. Okay, so just to transfer the load of the wall here. And if you want to assign it as a beam, like as a hidden beam, so what you have to do, you have to give the depth of the beam. Suppose you have considered 200 mm width, but the depth of the beam should be equal to the depth of your slab. Then only it will be hidden, right? So in that case, you can do that actually. So in that case, obviously the effective cover will be changed. So you need to you have to be careful about it. Whatever effective cover you are giving. So initially, maybe I will go with this value. I will change this beam size also, as it is only present in the plane, and will make it 200 by 350. Okay, I will go at the top and I will choose for all stories. I will choose this beam, beam, okay, and I will make it 200 by 350 for all stories. At the top floor, we don't need these beams also. Means at the roof, we don't need these beams, but let's keep it and we will delete it afterwards. At the roof, we'll make it one story again. The roof, we don't need these beams. And you can also, what I can do, I can also merge this. So I'm just doing it for the roof. Okay. So I think we are done with assigning the beams and we are done with assigning the floor loads, right? Now what we will do, I think we can also assign the can say wall loads here now. So what I will do, I will click on the plan view. So let me just set up the similar story option. Okay, I will go to edit stories and grid systems, and I will let me just check one thing. I think there is one issue with my view capture device. So what I will do, I will modify this. I will make the plinth level as my master story, and I will make the first floor as my similar floor. Okay, sorry, will make be no, and I will similar to this plinth level. This will be none, and the top floor will be none. Means if I assign anything to the plinth level with this option to be as a similar story, so the same thing will be replicated to the first floor also, because this particular story is similar to my master story plinth level. Okay, you can see here similar to plinth level, and the master story is my plinth level. Okay, and okay. Now I will make it similar story. I will go to the plinth level, plan, plinth. Okay, maybe I will select all the beams. Okay, I will select all the beams except this balcony. My plinth level, right? For the top level, this beam will be having the wall loads, but for now here it will be having the wall loads, right? So I will just take this here, and here. Okay, so what I will do, assign, go to assign frame loads, distributed will be SIDL. Let us calculate. Maybe here we have different sizes of walls in the plan, so for now I'm just considering maybe 150 mm wall, 150 mm 0.15. Here you can see 9-inch wall also we have. So just for our understanding, I'm just going with the same value now. 150 multiplied by the height of the wall. So we have considered 3 meter minus the beam depth, which is 0.4. Okay, that means the wall height multiplied by my unit weight of the masonry. So unit weight of masonry we used to consider 19.2. Let us consider with it as 20 now. Okay. So 7.8 kilonewton per meter load we are getting for the walls. Okay, for 150 mm wall. So I'll click on apply. Fine. So you can see the 3D view. The loads are replicated to this level also. Okay, so I'll go to the plan B of my first floor, and here you can see this beam we need to assign. So I will just, what I will do, I will make it one story now. I'll select this beam. I will assign here also. Okay, I will go down, and what you can see, if you see the drawing, see up to here we have the wall, and then we have a parapet kind of wall, like parapet wall. So what you can do, you can just let me go down. For this level we have not assigned any load on this beam, right? Because we don't have actually anything. So what I will do, I will go up and I will divide this beam. I will now make it one story. I will take this point. I will go to edit frames and divide frames, break at intersection with selected frames and joints, apply. Now we have this separated. So now what I will do, I will select this beam. Okay, and I will assign the load for the parapet wall. So maybe I will consider 1 meter height or maybe 900 mm height. If it is 900 mm, so the thickness of the wall, again, you can consider maybe 150 mm or maybe less than that, 0.15. The smaller size we can go with. And we can have 1 meter height or maybe 0.9 900 mm height. Let us go with 1 meter height multiplied by the effect unit weight of meson. Enter 3 kN per meter. And now what I will do, I will join these two beams. Here you can see I have the shortcut. Otherwise you can go to edit frames and join frames. So though this beam is a single beam, but this particular area of the beam having 3 kN and this particular area of the beam is having 7.8 kN. Okay, you can also see in the 3D view that variation that we have. Okay, where is the end layer? So you can see the variation of 3 kN and 7.8 kN. The same single beam. Okay, so it is a very good feature actually for in Etabs, that in the same beam, same continuous beam, you can have different. Okay, now I will go to the plan of roof level. The roof level, all these outer beams, periphery beams will be, see here we need to divide this beam because the total beam will not have the parapet wall, right? So I will just divide these two beams here. Any other beam? Yeah, here this beam also need to be divided. So I will just divide it here. Take an intersection. Okay. Now I will select this outer periphery beam. Not this stair area, because the stair area will be having a different loading. I will now assign the same 3 kN per meter line, and I will now join this beam. Here you can see, will join it, join frames. Okay, so this beam in this area we are having 3 kN, but in the other area, as we don't have any wall, so we don't have any load here. Okay, now this area, what we will have the stair room, right? So I will just select this beam, maybe. Obviously here we need to divide, but for now I am just giving it whatever load we are getting. So it was 7.8, right? So 7.8 goes, and you can see the loading that we have. If you want me to turn off the grid, so I will go to view and set grid system visibility. You can see how easily we have assigned the loads for all the whole structure. Okay, I got a job as a design and previous engineer by watching classes. I'm really grateful, and I'm really thank you. I'm really happy for you, Ashwant. It really means a lot that you are watching my videos and it helps you to get your job. That is really big day for me. Not only for you, it is a big day for me that you have learned from my videos and it helped you in your career. So this is really a good feeling for me now. Thank you for letting me know. Okay. So now I will save this, and let's just do the basic analysis today, and in the next session maybe we will go with the earthquake analysis and all. So we do have half an hour because it was 9 to 11 session. So I will just change the mesh sizes for this slabs. So I will go to analyze, and you have this automatic mesh setting for floors. Actually these floors are having the default mesh, you can say the meshing now. So I will change the default mesh size. I will go to this automatic mesh settings for floors, and from 1.25 I will change it to 0.5 so that I can get a pretty you can say very precise result for the load distribution, or you can say the moments and all. Okay, I will click on OK, fine. I will save it. So we have only the gravity loads. Okay, So now what I will show you, let me just run the analysis. Okay, I think here we have a higher deflection because this beam length very high. Let me see where is we have this in this particular area, right? Can we have a column here? I think we should have a column here. Here one column we have provided, but length it is going, I think how much it is, 12 feet and 6 feet. See, this deflection is pretty weird actually, high. So let us have two columns here, this area. Or maybe just 1 second. Where we can have a column. In between this, let me have one particular column here and let me check what is the result here. Okay. Though we have not changed the column orientation, I will explain it later maybe. It would change the column orientation as per the spans we have. So what I will do, I will go with all story. Take this quick column. Maybe I will place it here. I'll change the orientation to 0. Or should I have here one? No, let me have it here. I can change the dimension also, column dimension also. Yeah. In that case, see, these columns we can orient differently. Just I'm giving you one example. So this column we can change the orientation actually. Let us assign frame loads, frame and local axis. I will make it 90. Why I have changed this? Because if you see the loads that we will be having from here, this is a very smaller span in that direction, and we have two higher spans. But if these two spans, for this particular column, it is not an issue. If these two spans are similar, almost similar, so I think I should not orient this like this. I should change it. Local axis, I will make it 0. So why I have done this? I'll be explaining it later in a different session maybe. But see, here if you see this particular length and this particular length is almost same. Okay, so in this direction, okay, for this particular direction, whatever moment we will be having about this axis, so in both direction we will be having moments and it will be balanced. So the moment value maybe tends to 0 in that case. But in this direction, we have a smaller span here, we have a higher, longer span here. So in that case, when you will see that this moment will not be balanced by the load from two sides. Okay, so we will be having higher moments in this orientation. So that's why I have changed the column orientation. Okay, for these columns also, if you see for this end columns, now in that case you can orient accordingly because all the I think all the beams are same. Now for this intermediate column, it is a matter of concern because this column and this span are almost same. So yeah, you do not have to provide higher stiffness in this orientation because in this orientation the moment will be balanced. But for this corner column, in this direction we don't have anything. Right, in this direction we have load. in this direction we have load. Now like you can orient it anyway, because here also you don't have anything. It cannot be balanced in both the sides, so you just have to check in which direction it is critical, or maybe it is required for you as per your room placement, and you can change the orientation for this corner column. Okay, so suppose you do not want to suppose you want to have a bed here. So if it is oriented like this, so most of the part of the column will be inside. You do not want this, so you want to orient this like this, so that the column, most of the part in this orientation. So it depends on different criteria. So for now I will just keep this orientation. Let me just go to the 3D view, and by making it one story, I will select these two columns. Okay, and let's make all the base points fixed. Let all the base points, sign, joint, restraints fixed. Okay, so I have provided column here, one column here, right? Both the sides. So I will just run the analysis now. Yeah, now the deflection is less. So what you can do, maybe we will check. We can change the column size as per our requirement. Okay, so this is the model, and we can see the contours also, displays for the displacement and for the movement. So if I just, maybe I will go to any plan view. We'll go to show deform shape, maybe for the live load. Draw contour for displacement along in the z direction. So you can see here we are having higher displacement value, rz equal to 3.5 something. So yeah, you can move here. You can see that the places where we have higher displacements or deflections, you can see. Okay, if you want to see the moments, you can always go to the shell stresses here, forces and stresses for any load case, suppose, and I want M11, that means the moment along this X11 direction in case of the slabs or shells. So I will click on M11. Like, you can see the moment value in kilonewton meter, right? Kilonewton meter per meter. Okay, it is considering for per meter length these values. If you are seeing here, that means it is for 500 mm this side, 500 mm this side. 1 mm strip it is considered. Sorry, 1 meter strip it is considered for M22 moment. Now I just for our understanding. So what I will do, we have very less time left. So what I will do, I will just go to define, and I will create some load combinations automatically. Add default design combo, concrete frame design, convert user. Okay. So these two load combinations we have, dead load plus live load. Fine. And I will just go to view revise preferences for the design. The IS code I will keep, and I will design it. Okay. So why I am designing, just let me show you. So here you can see the moment, the area of reinforcement we are getting for this column, it is 960 mm square, right? So this is the longitudinal reinforcement that we are. Now let me do one thing. I will just select the columns, select object type, and I will select the columns, select close, right click. I will just go with show selected objects. Okay, and I will select all these columns. I will unlock the structure. I will select all these columns. I will go to the design, and here if you see we have this view revise overrides, and see the framing type we have considered ductile, though we don't have any you can say earthquake load. Okay, so we are designing this structure with the criteria of IS 13920. So if I change it to ordinary, okay, and I will click on OK, and I will run the analysis. and I will run the design. It is the same. It is the same we are getting, which is 960. Let us check another option also, because here we don't have the earthquake load, so obviously it will not consider the earthquake loads here. It is all the similar result we are getting. So another option we have non-sway. So I will just select these columns. I will go to here, view, revise, overrides. I will change it to non-sway. Now, why this non-sway? If you see, we have two criteria for sway and non-sway. It is IS 456, and I will go to NXE most probably. Check. Hi, sir. Hi, Mr. Zunaid. Yes, this is Illustraca, my channel name. Where it is IS 456 NXE or something like this. It was forgot the Q factor. Yeah, here. Yeah, NXE. So to determine whether a column is a no sway or a sway column. That means there will be a sway. Sway, we know the lateral displacement, so lateral movement of the column. So whether this column is a sway or non-sway, this is the formula that the code gives us. Okay, and you need to find out whether this column is sway or non-sway, and according to that we need to design the column. Now, if I like the software is considering it automatically, but still, if as I don't have any earthquake load, if I click on this non-sway, I'm just overwriting the design criteria. Okay, the design options. So I'll click on OK. Let's check whether it is changing the results in that case. Let me run the analysis again. I think we need to do after analyzing it. Let me check once. Let me select this now. Yeah, I think here we need to do non-sway. Fine, click on OK and design it. So here we have seen no change, but in few cases you will see that there will be a drastic change of reinforcement area when you are changing it from ductile to you can say ductile to non-sway or ductile to ordinary. Okay, most of the time when you have earthquake loads, then obviously when you are designing the structure with ductile condition, it will be always designing with higher reinforcement, because it is considering the criteria or considering the provisions of IS 13926 to make the column more ductile. Okay, so these are the, you can say this is the basic design process. Let me just show everything, show all objects. Yeah, the basic design process. You can also design the slab depending on the strip or depending on the finite element based method. Okay, so I am today, it's already 10:52, almost 2 hours we have spent here. So I think it is enough for today. In our next sessions, I will try to cover a few more things. I will try to go in depth regarding these concepts. Okay, so yeah, now we have 6 minutes. If you have any doubt or any question, you can ask in the comment. Or if you have any suggestion, it is always welcome. Yeah, see at the high, you have got high rebar at the top stories. Yeah, when you have earthquake load, okay, when you have earthquake load, you will be having high reinforcement at the top stories, because a very pretty like I will just explain it in a very simple way. So the column will be going like this, right? So in that case, the unbalanced moment used to be very high at the top. The unbalanced moment I have just talked about. Okay, suppose in case of gravity, you have a column, you have a beam, same span, similar span, right? So in that case, the bending moment you are getting in this particular column from both the sides like this, right? So it will be cancelled. So there will be zero bending moment in this orientation, right? So this that means the moments are balanced. But if you have a smaller span here, obviously in this direction we will be having higher moment, and in this direction you will be having smaller moment. So that means you will be having an unbalanced moment in this particular direction. Sorry, in the larger direction. So the amount of, again, this is only for the vertical load, like gravity load. Then when you have a lateral force, that will be different. So at the top stories, the unbalanced moment used to be very high. Okay, when you have earthquake loads. So that's why you will be having higher reinforcement at the top story. So if it is small structure, you can always continue the reinforcement at the top from the bottom. We should do that only. In the higher structures, you need to see you can say few more concepts or few more things. If you are getting higher reinforcement, very high reinforcement at the top, maybe you need to change the column size at the bottom, or you need to check what you can do. Actually, it is possible to provide. I don't know if I have joined or not. It is possible to provide higher reinforcement at the top, then the bottom, the reinforcement at the bottom. But we always prefer the equal, or you can say symmetric. Sorry, not symmetric. The word should be uniform reinforcement from top to bottom. Okay. So yeah, you can do that actually. No. Why should you make it over reinforced? When you will be having over reinforced sections, it will be like you will find brittle failures, right? You will be having cracks in a very initial stage. So you should not design with over reinforcement, obviously. To make it ductile, you should not design it over with over reinforcement. So that's why you need to check what is the reinforcement percentage you are getting. Like if you are getting column reinforcement percentage 3%, 4%, this is over reinforced, right? Though code allows up to 6%, but we should not go with 3% and 4% column, which is very uneconomical. Okay, Mr. Devanjan is saying make a video on design of shear wall. Sir, already, Mr. Devanjan, I already have 2 videos on shear wall design, considering the values of STAAD Etabs and also with the manual formulas from IS 13920 and IS 456. So please do check in my channel. There are 2 videos already available, which are the similar kind of live sessions I have taken, and it is almost like 1 to 2 hours, both of the sessions, where I have explained in detail how we can design the shear wall in Etabs, as well as how to do that in manual approach, considering the values or results from the Etabs. It is there actually. Please do check in my YouTube channel. It is very recent videos. Maybe I don't know, not recent. Maybe 4-5 months, or sorry, not 4-5 months, 2-3 months back. Okay. So thank you all of you for joining this live session. I'm really grateful, and I'm very happy for Mr. Yashwant. It is really means a lot that you learned from my channel and it helped you to get your job. I'm not saying that totally helped you to get your job, but at least some contribution from my videos you have in your career. That is really means a lot for me. It is a proud moment for me myself. Okay, thanks a lot. And yeah, those who want this plan, some people have asked me for this plan. You can mail me. The mail ID is Sandeep Dev. Previously also I have given. The mail ID is Sandeep, or everything is in small letter. Okay, Sandeep Dev 321 at gmail.com. Okay, so you can send me a request on this mail. I'll be forwarding the floor plan to you. Okay. If you want this Etabs model, I can send this Etabs model. Thank you so much again, all of you, for joining this session. And I will try to do such live sessions from now frequently. every week, so that we can continue. Like there should be a continuation of this learning process, right? So I will try to do that, and I need all of your support. Obviously, I'm getting all of your support every single day, and I hope it will be continued. Thank you again, and I will be signing off for today. See you in the next session.